Hi everyone, David Millington here from Parnassus. Hopefully you've heard of Parnassus because we make some cool Delphi plugins. And the skill sprint today is going to be on the topic of developing IDE plugins for RAD Studio that's both Delphi and C++ Builder. The materials for today are available at the short L you can see on the bottom left, embt.co/sprintplugins. Feel free to also send me an email at dave@parnassus.co, or you can follow me on Twitter at Delphi_Dave. The skill sprint works with both C++ and Delphi Seattle. The example code is all in Delphi, but it's all completely applicable to C++ as well. Both the C++ personality inside the IDE and also that you can write the same code using C++ Builder to write a plugin with C++. However, it's Windows only because the IDE only runs on Windows. So what are we going to look at today? We'll start off with the basics, which is what an IDE plugin is and how to write one. We'll look at whether to write a plugin in the form of a DLL or a BPL, and then we'll make a very simple plugin, a simple wizard as they're called. This will show an icon and some text on the splash screen and the about box, and also have a menu item. And then after that we'll show debugging the plugin under Delphi itself. And this is the point that most plugin material that I've seen before stops, but today we're going to go on much further. I'm going to introduce you to notifiers, which are one of the key mechanisms that are used for communication between the IDE and your plugin. Then go on to dockable forms. So if you want to have a window inside the IDE that can dock just like the project manager or the messages view, how to do that. And finally, a very quick example of how to draw on the code editor, which is something that's become newly available in Seattle. So what is a plugin? Well, it's simply code that you write which extends the IDE, adding or changing features. The IDE has many interfaces defined in tools_api.paz, and you can use those to access many aspects of the IDE. But a couple of the interfaces are wizard interfaces, and a wizard is what Delphi calls a plugin. So you implement a class that implements a wizard interface and register that class with the IDE. And there's a global ball and IDE services interface, which you can think of as a global instance representing the entire IDE. It supports a vast number of interfaces, which are defined in tools_api.paz. And through those interfaces you get access to many parts of the IDE. So we'll have a look at this in practice in a moment, but this is just a rough overview. So before we get stuck into actually writing a plugin, there's one important question, which is whether to write your plugin as a DLL or as a package. Of course, you can write using either, and you can change your project from being one to the other fairly easily. Both are loaded on startup when they're registered in the registry, but a BPL can be loaded or unloaded at any time, which is very useful for debugging. And so many people write a BPL plugin when they write their first plugin. But I would strongly recommend that you only ever use DLLs, not packages, and the reason for this is unit name conflicts. An application plus BPL system is quite complex. The whole system can only ever have one unit with a given name. So that means that your plugin, your BPL plugin, must never include a unit name that any other BPL, such as other plugins or other components, will use. And that means that you're really restricted by what third-party code you can use. If you want to use graphics32, for example, in your plugin, and you add gr32.paz to your plugin, that immediately means that no other plugin and no other component can use gr32.paz. Whereas if you use a DLL, that issue simply doesn't arise. So my personal recommendation is to always use a DLL for your plugins. So let's get started writing a very simple plugin. So to make a new plugin, let's create a new DLL project. Standard DLL, as you can see here. And we'll just save that somewhere. Example plugin.dproj. So far so good, and let's create a new unit which is going to contain the wizard. And the first thing to do is to make it use the tools API unit. This is the unit that contains most interfaces that are exposed by the IDE. As you can see, it's vast. There are dozens, perhaps hundreds of interfaces here. The one that we're after, though, is a wizard. So there are quite a few types of wizard here, but we just want a plain IOTA wizard, which has quite a simple interface, has a name, state, and an ID string, and an execute method, which is rarely called. So let's save this unit. And we create a new example wizard like so. So it's an interfaced object because it implements this particular interface, and the lifetime is managed by the references as normal. But instead of just creating a normal wizard, I'm actually going to create a different one, an IOTA menu wizard, which inherits from the normal wizard. The reason for this is that it adds an extra method which creates an item in the help menu. So you can see here in the help, there's a help wizards dropdown containing a number of items. So the IOTA menu wizard will add an item here. Now you don't need to do that very often, it's just for the sake of this quick demonstration. It's an easy and quick way to add a menu. So let's fill in the various functions that we need. And IOTA wizard descends from IOTA notifier, which is a very common interface. We actually don't need to worry about any of these methods at all in a wizard, but unfortunately we have to implement them anyway. Let's just put them there, get rid of the comments, and complete. So these methods that belong to the notifier we'll just put right down at the very bottom, and we don't particularly need or want to implement them at all. Okay, that leaves us with a number of useful methods here. Execute I'll get back to in a second. ID string just returns something useful. It's a dotted scoped ID string normally. Something like myCompany.myPlugin will do for that. Menu text, this is for the menu wizard and is the caption of the menu item that will appear here. Let's call it something like that. The name of the wizard itself. So this is an example plugin. And wizard state, really don't need to worry about that, but let's just say it's enabled. So far, so good. Now the execute method is going to be called when the menu item is clicked. So let's put that down here near the menu item name. And let's just simply show a message box. Okay, so the idea is we have a class here which implements these two interfaces which are defined by the IDE. They create a menu item in the help menu, and when that menu item is clicked it will show a message box. This isn't very useful yet because we actually need to register the wizard, we need to create the wizard. And to do that we need to export a couple of functions from the DLL, and when the IDE loads the DLL, when it loads the plugin, it's going to look for these exported functions and call them. So in order to do that, I'm just going to copy and paste in some pre-prepared code. First of all, we need to export a method that we actually want the IDE to call. Now you can see on the screen here, I've exported the same method twice with two different names. The reason is that the documentation claims that the name of the exported method needs to be wizard entry point. Unfortunately, if you just export that, then it doesn't work. The IDE won't actually load the plugin. And it turns out that the method name it's looking for is this one, initWizard01. So I tend to export both. I export the one that actually works, and I export the one that the documentation lists. So what is the method that we're actually exporting? Well, it's called initWizard, although it can be called anything. It is a twizard init proc that's defined in the Tools API if you want to look it up. And the important thing is that we're past this callback procedure here. There's a callback into the IDE, and we call that callback passing in initialize wizard, which is our own method that finally actually creates a wizard instance. So let's write that method. It's very simple. All we do is return an instance of tExampleWizard. So basically the loading procedure is that the IDE sees that the DLL is listed in the registry, which we'll do in a moment. It calls initWizard01, which is this method, which calls a callback that the IDE defines, and eventually calls initializeWizard, like our own method, which creates an instance of the wizard. So far so good. So we're very close to actually having a wizard that works. There's one more thing to do, which is to change the packages. So if we go into the project options and we look at the runtime packages, we actually want to link with the runtime packages, but we don't want to link with all of them. Let's just delete that. We want to link with the VCL and the RTL, of course, and Design IDE, which is basically the IDE designer package. So we might just have to get rid of the inheritance. Design IDE, VCL, RTL, done. So let's build that and check that works. It doesn't because that is a set, not an enumeration. Okay, that's better, building without any warnings or errors. In order to actually to load the plugin has to be registered in the registry. So let's find where this DLL is built. We can copy the path. And in the registry, you need to be in the BDS, your version, and experts folder here. Create a new string value, and we'll give that a name, example plugin. The name itself doesn't really matter. And we put in the path to the DLL itself. So all DLL plugins are registered here in the experts folder. And so that means that when Delphi starts, it will enumerate all of these and try and load each one of these plugins. So to actually run the plugin, we want to change the parameters. We want a host application of Delphi itself, the parameters of Delphi profile, and let's see what happens. Now at this point, we're actually going to be debugging Delphi under Delphi. So by changing those parameters, we are now running Delphi, and then at some point Delphi is going to load the DLL. Now when you load Delphi under Delphi, you get a large number of exceptions as it starts up. You can just ignore all of these. Notice nothing appears on the splash screen for our plugin yet. That's because we haven't actually coded that bit yet. Great. So if we look at the help menu, we should hopefully have an example menu item, and that's the menu item that we registered with Wizard. Click it, and we get a message box. That's fantastic. So let's show an example of debugging. You can see here the message box that we just showed. Let's put a breakpoint there. Go back to the debugged instance of Delphi. Click the menu item, and you can see we get a standard breakpoint. So in this sense, debugging a plugin is no different to debugging everything else, except that you happen to be running Delphi under Delphi, which is really quite cool. Let's terminate that, and we'll move on to adding a splash screen and about box icon. So I've created two bitmaps, which I want to show on the splash screen and on the about box. Just zoom in here. These are just two completely random bitmaps. This one is going to be on the splash screen, just a few colors, and this one will be on the about box. Now in older versions of the IDE, you were supposed to anti-alias the splash screen bitmap against black and the about box bitmap against white. In Seattle and above, possibly earlier, the interfaces have been extended so you can actually pass in a semi-transparent bitmap. For the sake of demonstrating things now, I'm not going to. This is just a completely ordinary, non-transparent BMP file. Both these need to be 24 by 24 pixels. I'm going to add them to the plugin as resources. So let me add a new resource file. And I'm going to add both those as bitmap resources. Okay, so that means that the bitmaps will actually be compiled in as resources into the DLL, and so we can load them from the DLL instance. So back to the wizard. Of course, we have a very simple interface here. What we actually want to do now, though, is add the splash screen and the about box information when the wizard is created, and we need some bitmaps. So let's create those, and constructor and destructor. And I always prefer keeping a certain order to my methods, so constructors and destructors belong up at the top to me. And we also need to add vcl.graphics to the users. Let's just initialize everything to nil. And now let's create some methods to actually add to load the bitmaps and to add them to the about box and splash screen. And again, let's rescue these and put them somewhere more useful. So first of all, let's load the about box bitmap. So if it's not assigned, then create it. We load it from a built-in resource, and that's the resource name that we gave. Then let's find the about box interface that the Ball and IDE services implements. This is an example of how the Builder and IDE services big global object implements a vast number of interfaces. This happens to be one of them. So let's add plugin info, and we have a title, example plugin, and the bitmap. We need to have a description as well. We won't really bother with the other parameters, but this lets you put information on the about box about whether it's registered or not. So if you have a commercial plugin and you can figure out yourself whether it's licensed or not, you can put information about whether it's licensed and the license value, whether it's in trial mode or whether it's actually bought, that kind of thing. But we won't bother with any of those, we'll just leave that as is. Now we need to do something very similar for the splash screen info. We'll load the bitmap on the resource name that we gave. But this time, instead of using Builder and IDE services, we use this instead, splash screen services, which is defined here in the Tools API. The reason for this is that when the IDE is showing the splash screen info, it isn't fully initialized yet. So we have this special object that gives access to the splash screen at an earlier state than the whole Builder and IDE services. So let's look at that. We'll add a plugin bitmap. Describe our plugin, of course. And again, you can also give information about the license status, whether it's registered or not. If you pass in that it's unregistered, for example, then the text will appear red on the splash screen, but we're not going to bother about any of that today. So we have two methods to load bitmaps and to add them to the about box and to the splash screen, and those are called when the wizard itself is created by the IDE. So let's try that and see what happens. When we run, we should hopefully see our wizard appear with an icon and example plugin appear on the splash screen, and then later we should be able to look at the about box and see the same information. Let's try it. And there we go, we can see our example plugin bitmap and our text. And if we now go to the about box, we can see in the installed product section here our example plugin with our example description and our icon. So there we go, we have both icon and name and description on the splash screen and also the about box. So let's start moving on to some more advanced stuff. In this case, let's add a dockable form. In order for a form to be dockable in the IDE, it needs to descend from one of the IDE's inbuilt dockable form types. So if you want to do that and you also want to be able to use the visual form designer in the IDE for your plugin form, how do you do that? Well, quite some time ago, Alan Bauer published some mock-up units. This is back in the Delphi 5 era, for a dockable form and a few units that it required. And you can add this to your project in order to make the IDE work with visual form inheritance. Unfortunately, this code and these forms are very old now and don't completely work in the modern version of the IDE. So I've modified them and changed and fixed a few things, and I will make these available as a download after the skill sprint. So to make a new dockable form, we'll start simply by adding a new form. And add VCL to the project, and we'll save that. We'll call that the example form. We need to make it inherit from one of the IDE's inbuilt types. So that'll be tdockable toolbar form base. And we should also change that to be inherited. Now, right now, if you try to view it as the form, it won't be able to view it as a form because the ancestor form type isn't found. So let's help the IDE out a bit. You can see here this dockable forms folder contains some modified versions of Alan Bauer's original files, and also a new base form, which is my own, and I'll make that available as part of the download as well. So let's add that. We also need to add Alan's other files. Ignore all these various errors. I'm just going to remove that and re-add it. So this is my own version of the IDE's inbuilt dockable form type. It's heavily based on Alan's, of course, and you can see it has a few menu items, that kind of thing, and a toolbar. So if you look at bookmarks here, for example, bookmarks actually uses this as an ancestor form type, and you can see how I have added to the toolbar. So let's go back to our example form. We should now be able to view it, and we can see that now through the magic of visual form inheritance, we also pick up the toolbar and we pick up the other controls. So let's save that, and then let's remove the ones that we actually can. One of them won't work. What that gives us is that we have my own dockable form base, and then Alan's as well, which is the ancestor of my own. And then we have a dockable form, which you can see here, which inherits from all of those. So this is rather convoluted, but it allows us to access the IDE's own dockable form base type, fake it to the IDE now so that it can use visual form inheritance, and then through the intermediate class that I created, which has a few more features, you can then inherit your own dockable form type. So let's add something interesting here. We'll just add a memo, and we'll align that to the client and set the font big enough that we can actually read it, and put some text in there. Fantastic. So we now have a dockable form which contains a memo and it has a message. When we next run the plugin, we should be able to see and recognize this form on screen. The form should be created when the wizard is created, and it should be freed when the DLL is unloaded. So let's write some code to do that. So first of all, let's give it a better name than form1. And we'll create a method that allows us to create the form. Because the form is going to be created once and we want it to be accessible from outside this unit, we'll leave the IDE's auto-created variable here. Now we want the form to also work with the desktop saving system. That's this thing up here, the different layouts, your default layout or the debug layout. If the user opens your form and docks it somewhere, then you want your form to be placed back in the same position or in the same tab next time the user reopens the IDE or next time they change layouts. So to do that, we'll use this code here, which is copied and pasted from a presentation done by Bruno Fierens, and I'll add a link to that in the resources at the end of this skill sprint. However, for this to work, we need to add a few items to the users clause, like so. So this will allow us to create the form and register it into the desktop layout system. We also want to get rid of the form when the DLL is unloaded, so let's do that here. So now we actually need to create the form when the wizard is created, and I'm just going to change this so it's a normal procedure. It doesn't really need to belong in the form. So we're going to call this method createForm when the wizard itself is created. So to do that, let's go back to the wizard. Let's add the form to the users clause, and we'll call createForm here. So at this point, the wizard will be created, it will add its info to the about box and splash screen, and then it will come along and create the form, register it into the desktop system. However, the form itself won't be visible. To make it visible, you would normally have a menu item in the View menu or the Tools menu, but right now we actually already have a menu item which is in the Help menu. If you remember, it showed the message box, so let's just reuse that, which was here. So instead of showing the message box, that's our example form, and we'll call show dockable form. This is one of the methods that I've tweaked and fixed since the Delphi 5 era ancestor form. It means that the form works much better in a modern docked IDE. So show dockable form, for example, will, if it's invisible, will show it. But if it's visible but tabbed, for example, one of these tabs here, then calling show dockable form will also bring that tab to the front, which can be very useful. So at this point, we should have something that compiles. Great. And what should happen is that when we click the menu item in our wizard's help, the dockable form becomes visible. So let's just run the IDE and see what happens, skipping through the various exceptions. Our example plugin is loaded. At this point, our form actually already exists. What we want to do is look in here. We have our example menu item, and we have a form. You can see when I drag it, you get the blue transparent drag shape that you do normally in the IDE. We can also dock it. So let's dock it there, and it forms a tab. Dock it over here, put it over here, make another tab there, or drag it out here, wherever you want. You can see there's a tiny gap here where the toolbar is, and of course you can write code to hide that if you don't want a toolbar, or you can add toolbar buttons the same way that the bookmarks form does. So that's the basics for having a dockable form, a form that is native to the IDE, just like the other forms that are built in. Now let's have a look at notifiers. Notifiers are really common in the Tools API, and they're one of the main methods that the IDE uses to communicate back and forth between the IDE and a plugin. Now there are a vast number of different types of notifiers defined in Tools API. Look at all of these interfaces, all of the other random types and functions. All of these basically allow you to implement one of these interfaces, and then you register it with the IDE, and then when certain types of events happen, the IDE will call into your class that implements one of these notification interfaces, and then you can react to the event. But we're only interested in one particular type of notification, just for demo purposes. This one is going to be notified when files are opened and closed. And for the sake of time, I'm not going to write the code live. I'm going to use a unit that I've already created. So let me add that here. You can see, first of all, that it implements the base notifier interface, but the key one that it implements is IOTA IDE notifier. And what we're interested in are these particular events: a file notification with a file name and a code saying what kind of file operation it is that's happening with that file. And you can also see here there are events for before something is compiled and after a project is compiled. So in this notifier, again it's an interfaced object, I've implemented these three methods and is going to log the events to a t-strings. So if we have a look at the implementation of those events, the file notification, there's a vast number of different codes, but here we're just interested in if the file is opening or closing, then we'll add a message saying that something happened for that file name. And also before compile and after compile, we'll add something to the log. In this case, we'll take the project file name and the application type and the platform accessing some of the project properties. You can see here IOTA project is another inbuilt Tools API interface. There's a vast number of stuff you can access. So if it's going to write output to a t-strings here, we happen to already have a handy t-strings in terms of our dockable form, which has a memo. So we're going to write some really ugly code and put the notifier right in the form. Of course, you want a much better architecture than this in your real code, but this is a quick example. Let's create a constructor and destructor for the form. And then we use the same wall and IDE services global instance. So let's access that. In this case, we're accessing IOTA services, and we call add notifier. So let's create our notifier. First of all, let's add it to the users clause. And we'll create one accessing the memo. Now, add notifier actually returns an integer, that's an integer ID, and so we want to store that so that we can actually remove the notifier later. And save it. And then in the form destructor, we need to remove the notifier and pass in that index. It's important when you use notifiers to always remove them when you add them. The lifetime of notifiers can be a little bit tricky depending on which type of notifier you're using, but in general, if you add it, you need to remove it. So this gives us a notifier that exists the moment that the plugin form exists. As I said, this is quite architecturally bad, but just for proof of concept. And it will log all the events it sees to the docked form memo. So let's try that and see what happens. Since this exists as early as the wizard itself exists, when the dockable form is shown, we should actually see a number of notifications already. And if we open our dockable form, we can see that yes, we have got a number of file notifications. So there are notifiers for many different parts of the IDE. So if you just search for add notifier, for example, you can see that you can get notifiers for the editor, for edit blocks, for an edit view, for modules, which are files and forms, that kind of thing, for breakpoints, for threads, processes, for the debugger, for the messages, for the to-do, for IDE Insight, for compiling, for all sorts of things. And all of them follow the same basic pattern. You add a notifier and then methods get called in that notifier object when a certain event occurs. So that's a very quick introduction to notifiers and how they work. Now let's have a look at a slightly more interesting type of notifier, and this notifier will allow us to paint on the code editor. So notifiers are used to allow your plugin to hook into any number of events, and of course painting is an event. So let's have a look at this particular interface here. INTA edit view notifier. So what is an edit view? Well, this here, where the text is an edit view. The idea is basically that you have the file contents, and then you can have a number of different views on those file contents. So for example, I can right click here and I can create a new edit window. And if I resize that smaller, you can see here that I have two completely different views of the same contents. So roughly speaking, this is a view. And that view is what we want to paint in. So an edit view notifier has events basically when the editor is idle, when painting is beginning, when painting is ending, and this one, which is one that we're actually interested in, a method is called when each particular line is painted. And you'll pass in the view, you'll pass in the line number, the line text, a whole bunch of attributes for that text, and a canvas. So again, to save time, I'm going to add a file that I've already created. And I call that a view paint notifier. And as you can see, it implements the edit view notifier interface that we were just having a look at. And we have the paint line method, which is the one of interest. Basically, this saves the canvas state that we're about to change, changes the canvas font and brush color, and then draws some right-aligned text, which is the line number of each particular line. Finally, it restores the canvas state. When this method is called, you have no idea what state the canvas is actually in. It's simply called after the IDE has finished all of its own painting. So you do need to make sure that you set everything up exactly as you need it. And of course, it's good practice to return state back to how it was at the end of the method. So how do we use this notifier? Well, this notifier notifies us of events for views, so we need to add a notifier to a particular view. And I'm going to do that in a really hacky way this time, just to demonstrate something that works, which is that I'm going to take our example docked form, and I'll just add a button that will let me do something. In this button, we're going to find a view, any view. The top view is what it's called, which is the sort of current, the focused view, and we're going to add a notifier to it. This is really hacky. You should definitely use a much better structure than this. You should add a notifier that notifies you about when views are added and created and hidden and shown, and you should add and remove your notifiers to each individual view correctly. However, just for the sake of demonstrating something, we're just going to add one notifier to whatever happens to be the top view when this particular button is clicked. Let's add some code that I've already written. We get a view, which is an IOTA edit view, and we ask the Ball and IDE services as yet another interface for the top view, and that is the current tab, effectively. And like all notifiers, we have a index, so let's add that, and in the constructor we should set that to -1. And we're going to add a notifier to the view, which is our view paint notifier that we just created. And we should also add that to the users clause. As I said, this is really hacky and is simply proof of concept just to show you how you can get a notifier for a view and how you can paint on the editor. So as an overview, what will happen is when the user clicks the button, if there is no notifier already, then we will add a notifier for the top view, and this particular notifier has events for painting, and in the paint line event we're going to draw in red on the right hand side of the editor the line number. So let's see what happens. So let's open our docked form, and we'll click our button, which should add a notifier for this view. And then we need to cause a repaint event. We can do that just by clicking. And voila, suddenly we have, in bright red text on the right-hand side of the editor, the line numbers for every line. And of course we can scroll and we can see those are updated. So there you go, that's how to paint in the code editor. This is new in Seattle. Before Seattle, getting access to the code editor required a large number of hacks, but in Seattle, Embarcadero added an interface to the Tools API giving you access to the editor painting. So that's most of the material for today. A quick overview of what else is possible with plugins. You can add menu and toolbar items, and you can access the project manager, open projects, files, and modules. You can create wizards for adding new items to the repository. Through interfaces and notifiers, you can get info about or control, edit views, modules, forms, projects, breakpoints, the debugger, including evaluate, modify, processes and threads, messages, version control. You can read and write code in the editor. You can do an awful lot of stuff. And also via hacking the IDE, you can access things that aren't published. So a quick overview of what we've covered today. We've learned about plugins in general and wizards, which is the IDE's internal name for a plugin, and about writing plugins in DLLs versus BPLs. I always recommend using a DLL. We've written a very simple plugin which has information on the splash screen and the about box and has an item in the help menu. And we've shown debugging a plugin, in other words running Delphi under Delphi. And then we got into some of the more complex topics. We covered notifiers and what they are and how they work. Then dockable forms and the slight convolutions that you have to go through to get one to work, and also views and painting on the code editor. And I think this is a great beginning. With that as a basis, you can write some amazing plugins, and I hope you do. So what resources are out there for learning more about plugins? Well, the example code for this skill sprint will be available, so you can download it at the URL you can see on the screen, embt.co/sprint-plugins. The documentation, the DocWiki, actually has quite a lot of material as well, and there are a couple of other resources that I would highly recommend. The first is David G. Hoyle's blog. He has written a large number of posts investigating all sorts of parts of the Open Tools API. And the second is Bruno Fearon's Extending the Delphi IDE. That's available on Embarcadero.com. So we'll move on to questions and answers in a moment. Meanwhile, check out Parnassus Bookmarks. This is a plugin that I've written. It's free. It's an IDE bookmark replacement. You saw it in the presentation just then. And also check out Parnassus Navigator. That's code navigation to jump around in a unit. It adds the minimap. You saw that being used today as well. Navigator and Fix Insight, which is a static code analysis tool by Roman Yankovsky, are bundled together this month in December. So you can buy the pair of them as a bundle and save about €40 or so, which is a great deal. So check that out. Both of them have free trials, so you can download them, try them out, see how awesome they are, and get them. So thank you very much for watching, and I hope you found it really useful. And now we'll move on to the questions and answers.
Okay, fantastic. Thank you, David, for that great session. Lots of good information in there. It was kind of coming out as fast. Kenneth Davis adds, wow, this is so cool. Thanks. I would certainly echo that as well. I think this is very cool, very useful, great information there. Thank you.
Well, that's great feedback. Thanks very much.
So now you did say that all this code could have been written in C++ just as easily as in Delphi. Is that correct?
That's correct, yes. Of course, you use the Delphi interfaces, but of course, you can access Delphi interfaces in C++ Builder quite easily. So you can certainly write a plugin in C++ without problems.
Okay. I know I was thinking about it ahead of time of the session, and the IDE is written in Delphi, and most of the plugins are written in Delphi, but there's no reason it can't be written in C++, which is kind of cool.
Yeah, that's true. I personally prefer to write plugins in Delphi simply because I find it easier to use the Delphi constructs-like interfaces from Delphi rather than from C++, but I know the IDE is, as you say, mostly written in Delphi. I'm sure it has bits in C++ as well, and certainly if you like C++, then you can definitely write your plugins in C++ without trouble.
Does this work only with VCL or also with FireMonkey? I guess he's talking about the dockable forms. Can they be FireMonkey forms or they could be VCL forms?
Well, Delphi itself is written using the VCL, so the dockable forms should be VCL. There are a number of hacks that allow you to mix and match FireMonkey and VCL, and I know that Delphi does something internally with the FireMonkey form designer. I have certainly never tried to put a FireMonkey form in a plugin, and I have no idea if it would work or if it would cause problems. I personally would stick to using the VCL, given that the Delphi is written using the VCL.
That's probably a good idea. I guess if there is this instance where you need to do a FireMonkey form, you could try, like you said, a number of the hacks that are out there, or just give it a shot and see what happens. But just know it may not work. Is there documentation for the tools API unit?
There's a reasonable amount, yes. So the DocWiki has a good sort of introductory amount of documentation. It will take you through a wizard and some basic notifiers, I think. The rest of the documentation, because there are a vast number of interfaces, I have no idea how many, let's say 100, 200, I have no idea. Most of the documentation is in the tools API.pas method itself. So it's very well commented, and all the interfaces and all the methods in each interface have comments explaining what they are and what they do. You do sometimes have to figure something out if you want to know that you want to access a particular part of the IDE. Sometimes you have to go searching through the tools API to see if that part of the IDE is exposed as an interface or not. But so in that sense, not everything is quite documented, but you can usually find what you're looking for. And when you do find something, the comments there are very extensive.
Okay. Stefan Glinke pointed out that the wizard entry point is a const in the tools API.pas, which contains the init wizard 0001. So where that part where you had both the interface, both exports there, apparently it may be able to be handled with just a single constant.
Yes, I might have made a mistake there. I'll have to look at that after the skill sprint and look it up.
That's always the great thing about doing these skill sprints, is that someone else comes along and says, "Hey, that's oh, okay." Now I know.
Very true.
It happened to me more than once. Do you have any advice about creating plugins that won't crash the IDE? I guess that
won't crash the IDE. Look, in general, I find it quite stable. There are a few things that will cause crashes, but in general, they're problems in your own code or a misunderstanding of how the interfaces are supposed to be used. Look, if you get into hacking the IDE to access some of the things that aren't exposed via the tools API, then you're on your own. But apart from that, I find that the only crashes come from things like, let's say, notifiers where you've got the lifetime wrong, or where you're keeping a reference to something past where you should keep the reference. And in general, you can figure that out, or it's documented. Usually things work quite consistently in the IDE. Perhaps you could expand on the question if there are certain things giving you trouble. I don't tend to find that writing stable plugins is a problem at all. I do have to point out that in some of the older versions of the IDE, such as XE and XE2 particularly, sometimes it can be troublesome, especially when the IDE exits. The IDE can have crashes that can be very difficult to track down. But the recent versions of the IDE are, let's say XE3, XE4 and above, are very stable.
Okay. I know that when you're writing a plugin, because the fact it is loaded into the IDE, if you have crashes in your code, then that can cause undesirable behavior in the IDE. So it's real important that you debug your own plugin, like you showed with running Delphi in Delphi, to track down those bugs in your code so that you're not contributing to problems there. So
that's right. Yeah.
Yeah, I think that's where you showed that you can run your plugin in Delphi from within Delphi and debug it. That's really, really important that you do that. I remember because long ago I tried developing an IDE plugin, and I was running into problems, and someone pointed out you could do that. I'm like, what? That's crazy talk. Sure enough, that made a huge difference for me. Do you have any pointers about how to work with the form designer, VCL, and FireMonkey? I'm guessing from within your plugin.
Look, there are interfaces that give you access to some things about the form designer, but I'm not very familiar with them because I haven't written anything that uses them. But I can tell you that there are some interfaces there. I'm not completely certain about FireMonkey, but I imagine that's there. I know for the VCL form designer, you can get access to it.
Yeah, the plugin I wrote years ago was a wizard that replaced BDE components with a different component set. We were moving from BDE to a different data access layer, and it went in and onto the form and said, "Oh, this is a BDE component," and then created a different component, the new library we're using, copied all the properties over so that it knew how to connect to the data, had that connection information into it, and switched it out. And then the idea is we did it form by form so that we could then go through and make sure that form worked correctly. And it was once I was one of those things like, how are we going to do this? And it's like, I bet we could do a wizard. And sure enough, once we got in there and started poking around in the tools API, it was very, very easy to accomplish that and to get that done. So I found it quite easy to work with. It's a nice system. Okay, so there was a previous Open Tools API RAD in action, and Alf's asking if we've had any major changes since then.
I'm not sure which one that is. That might be Bruno Fearon's one from a year or two ago. As far as I know, there are no major changes. So the IDE adds interfaces and adds new versions of interfaces each release, but it's always backwards compatible. So something that worked back in XE4 or XE6 will still work in Seattle. The changes are just that there might be more interfaces or newer versions of the interface giving you access to more stuff in the newer versions of the IDE.
Yep, that's the one he did.
Sure.
Yeah.
That's really good material, by the way. I highly recommend checking that presentation out.
Yeah, you'd referenced it in your presentation. Great session, David. Much to wrap our heads around. Yep, that's very true, Pat. This is something I'm going to come back and watch again. Now, you have a blog post that goes with this as well. Oh, there it is. It's up on the screen. David's already got that there for us.
I do, yes. So that basically just it shows you can see on screen the various topics. If you can scroll down slightly, I have a download available with the source code for the plugin that I developed in the school sprint. So you can download that and have a look at what it does. That includes the the slightly modified dockable forms that you'll need if you want to create a dockable form in the IDE.
Excellent.
And you're welcome to download and use that. And I'll put a replay up on this same blog post when the replay is available.
Yeah, we'll get that. We'll edit the Q&A onto the end of it and then post that on YouTube, and then you can link to it. That'll be great. Yeah, this is definitely one of those skill prints I'm going to have to come back and go back to your code and go through the video again and make some notes and try this out, because it's been too long since I've tried to do anything with the Open Tools API.
There is quite a lot of material in a fairly short time as well.
Yes.
I was I really wanted to get onto some of the more advanced topics like dockable forms and notifiers and drawing on the editor rather than just making a wizard.
Yeah, and I really appreciated that you got to that, especially like drawing on the form, because it's, like you said, it's something brand new that we've not seen anybody show how to do that before. So
yeah, I'm very glad you guys added that in Seattle. Of course, bookmarks, for example, draws on the code editor in older versions of the IDE, but I had to implement a number of hacks to do that. It's very nice in Seattle to actually be able to have changed my plugin to use an official interface.
yeah, there are so many great improvements in Seattle. I'm a huge fan of it as well. It's a great step forward. Okay, so David just put up on the screen. Here's the 2016 Skill Sprint schedule. We just now launched it, and there's the registration link, so you can get out there and register for that. We have 2 different tracks. On Tuesday will be the Delphi Object Pascal skill sprints, And then on Thursdays is the C++ skill sprints. And so it's going to be the same topics each week, but then on Tuesday, all the examples will be in Delphi, and on Thursday, all the examples will be in C++. And so that way, if you can't attend one, you can attend the other and just do the translation in your mind. Or if you have a preference and really want to make sure you see it in your code, in your language of choice, you can do that. So the sessions start January 5th through March 31st. There's the dates and times there. So check that out. Okay, I think we're to the end of our questions here. I'm sure everybody's going to go through this again and have some more questions. You okay if people contact you if they have questions later on?
Absolutely, yes. I put my contact details at the at the side of the front of the presentation. Also, as you can see, the blog post with the materials has a comment section as well, so you can also post there, and I'll reply.
That's a great resource as well. Absolutely. Fantastic. Well, thank you so much, David. This is a great presentation, and you do a great job explaining all these cool technologies and making it seem so simple.
Well, thanks very much, and I hope everyone found it useful.
Great. Well, thanks for this great session, David. This is a lot of good information in here. Okay, so a couple of questions here. During your presentation, there was a little micro version of the code editor along the side there. What was that we were seeing?
Oh, that's a plugin of mine that I wrote called Parnassus Navigator, and that has a little mini-map on the right-hand side of the editor, like a mini-map being a view of the entire unit. Navigator also adds the go-to window, which you saw me using during the presentation. It's a quick way to navigate around a unit and get a list of all the methods, all the types, or whatever else I was using it to jump around between interfaces in the Tools API unit, especially.
Yeah, very nice. So a couple questions here. Actually, here's one on Parnassus Navigator. Does it work with C++ Builder well, or is it a Delphi-only plugin?
The minimap works in C++ completely fine. It's even syntax highlighted. But unfortunately, the go-to window requires, that's Delphi only. I only have a Delphi parser. I don't have a C++ parser. But the minimap half of it, which actually is quite popular, works fine with C++.
Cool. Brian said, very nice, useful presentation. Thank you. I particularly like the hacking of the IDE to implement form inheritance to accomplish something that the IDE seems to be trying to make impossible. Is there any part of the roadmap that would make this easier? Something obviously useful for us developers.
Well, I suppose you guys can answer the roadmap, but the problem with the visual form inheritance is that the form you're trying to inherit from belongs to the IDE itself. So really, what you saw was just a workaround to get a basic form that the IDE knew about that it could inherit from that was compatible with the form that's actually in the IDE. It's not particularly tricky. Once you set it up once, then you can do it again easily. So that's it's probably not a big problem for plugins. And the code to do that is actually included with the downloadable materials in the blog notes. So you're welcome to download that and make use of that dockable form and all that kind of thing.
I think that's going to be a good resource there, is having that, and then the resources you pointed to, and to be able to just get started with this and get going. So excellent, yes. And you also said that it's easier to develop with BPL because you can unload it and load it as you need to, but that the DLL is better as far as the wizard for deployment purposes because of you get around the naming collisions. Is it easy to develop it as a BPL and then switch it to a DLL later? Is that a feasible method?
You certainly can, yes, because all the classes, all the things like the wizards are exactly the same. It just depends on what the project type is. But I personally find it quite easy to develop as a DLL right from the beginning. As you can see, I made a new DLL project there and then added it to the registry, and that's not particularly hard to do. And then, like all of my plugin development, I do as a DLL right from the beginning. I never try to use a BPL. So you certainly can switch between the two if you want to, but like my personal recommendation is just start with a DLL and keep on going.
Yeah, it certainly looked like it was plenty easy to do that with the way you were just firing up the IDE from the IDE and debugging it there. So yeah, that's a good point. Is there modern documentation to the IDE plugin interface?
Yes, there's quite a lot. So the doc wiki, like the Embarcadero documentation, has a reasonable amount about the Tools API. Like it certainly has enough to get you started on what a wizard is and adding menu items, that kind of thing. That includes menu items in other places other than the help menu. So it'll get you started on what a plugin is and how to write one and what the interfaces are and how to use them in general, notifiers, that kind of thing. But there are a vast number of interfaces in the Tools API, and you do run out of documentation eventually. But in Tools API.paz itself, everything is very well commented. So you can basically read through Tools API, and there are extensive comments for every interface, and they function as rather good documentation.
Okay, good, excellent. Brian's saying that he worries that with the unofficial way of handling the form inheritance, that it could change in a future version of Delphi.
Sure. Well, having an official way would be great. I strongly doubt that it will change, simply because the code that you saw I used was based on code that was originally published in the Delphi 5 era, and it still works. So it's been compatible for however long that is. It's got to be close to 20 years now. And so I personally would doubt it would change significantly in the future. But if it does, it would be easy enough to create a new mock-up form, I think, that match whatever changed in the IDE.
So yeah, there was a great collection of resources you had there as well, which everybody can access from your blog post, which is at embt.co/sprint-plugins.
My blog on parnassus.co has a number of other posts about writing plugins as well. I think they're all far more advanced topics as well, things about hacking the IDE to access certain things. But once you if you are interested in writing plugins, then you can browse through the blog post history and have a look as well.
Excellent.
And of course, you're always welcome to email me or ping me on Twitter. The embt.co/sprint-plugins all takes you to a post on my blog, and that has a comment system. If you write a comment there, I will see it, and obviously any reply there other people will see as well. So that would be quite a good place to post questions or feedback.
With your plugins that you've created, the bookmarks and the navigator, were you able to access most everything you needed through the OpenTools API, or did you find you were hacking a lot of things, or what was your experience in that regard?
Bookmarks was quite easy. I could access almost everything I wanted through the Tools API. The one exception was painting on the code editor, because up until Seattle, painting on the code editor did require a number of hacks. But as of Seattle, as you saw, that's now available through the Tools API, and so the Seattle build of bookmarks uses the new API that I just showed you. So counting that, bookmarks doesn't require any hacks at all. Navigator does a few things. It like as you saw, it docked the minimap on the right-hand side of the editor, and so it has a little bit of hacking into the IDE to keep track of what views are visible and what's being shown on the view. For example, you don't want to have the minimap in the form designer, that kind of thing. But since Delphi is written in Delphi and it uses the VCL, it's actually very simple to poke around inside the IDE and find what you need to.
I think we're done. So thank you so much, David, for your time.
Thanks very much.
and we'll chat with everybody later.